Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Muhammad Akid Hazim bin Roswadi, number matrix A1829663. We are from group KK17. We will present IP project entitled Productions of Protein Feed from Microalgae. Protein consumption has increased in many countries as a result of population growth. Microalgae are photoautotrophs microorganisms that can grow on anthropic emissions and convert small molecules like carbon dioxide or ammonium into value-added macromolecules like protein. Therefore, microalgae farming is a promising alternative to couple the anthropic emission with the production of food and feed. Next is physical and chemical properties of protein. The physical state is liquid and colorless. The pH is 4 and the temperature is between 70 and 90 degrees Celsius and it is odorless. Next is usage of protein feed and application. Protein feed were used in pharmaceutical industries, human nutrition, food feed, and animal feed. Proteins are usually consumed as a dietary supplements to repair and build muscle tissue. Protein for microalgae are used as animal feeds including aquaculture, farm animals, and pets. List of companies and price. There are some companies in other countries that are producing algae-based protein feed such as Altec, Celana, and Duplaco. In the market, algae hold up to 18% on the source of proteins in the products. The market price of microalgae-based protein feed is about 150 USD per kg, which is about RM 624 per kg. Next is our plant capacity. The demand of microalgae-based feed is higher than the supply of microalgae-based feed based on the graph. Our proposed plan is to contribute 5% of the global microalgae feed deficient. Our plant capacity is about 148.41 kg per hour.
My name is Nur Nazmi binti Abdul Aziz, matric number A182785. Now, I will continue this presentation with our process description. There are about 3 processes starting from cultivation, centrifugation and drying process to produce our protein feed, which is dried Chlorella vulgaris. Before the microalgae undergoes photosynthesis in the photobioreactor, culture medium and the microalgae are inoculated into the seed fermenter. Cultivation process is done in a 14-liter closed photobioreactor at temperature about 20 to 25 degrees Celsius and pH medium is A. Through photosynthesis, the microalgae cell growth increase and oxygen gas are produced. Microalgae also undergoes anaerobic respiration which produce lactic acid. Next, microalgae and water is added into centrifuge. And centrifugal force is generated by rotation that spins at 8000 rpm for 10 minutes and separates the microalgae from the water and form a wet biomass paste at 20 degrees Celsius. Then the water is discharged out from the centrifuge. Finally, wet biomass paste will undergo drying process in freeze drying until the water completely removed in the vapor paste at temperature between 55 to 60 degrees Celsius. Our product, which is dried Chlorella vulgaris, is produced. So this is our block flow diagram, and this is our process flow diagram.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazahani binti Noor, A182708. I will explain about the safety and environmental issue. Safety issue is defined as any condition, practice that causes a substantial probability of physical harm. Safety precaution and substance handling and product management need to be emphasized to minimize the accident at workplace. Based on Occupational Safety and Health Act 1994, safety precaution important to ensure the wool process and plant are in a good condition. From the material safety data sheets, we can identify the hazard identification, first aid action, and protection equipment of the substances. We also can identify the substance handling and product management. 4 risks from the production of protein from microalgae are lactic acid, phosphate, nitrate, and carbon dioxide. The table shows the effect and treatment if the substances exceed the standard limit set by the World Health Organization. Environmental Waste Regulation. Environment Quality Industrial Effluent Regulation 2009 is a law applied to any premise that discharge industrial effluent into any soil or in the waters.
A very good morning to the doctors. My name is Avinash K. Bududharan and my matrix number is A18-1978. I'm going to present our mass balance, energy balance and our biologic task. Our work process consists of cultivation, centrifugation and drying. The mass balance of cultivation is balanced at both sides at 1314.3 kg per hour. Next is the mass balance of centrifugation process, which is also balanced at both sides at 180.31 kg per hour. And last but not least, the mass balance of drying is both balanced on both sides at 156.56 kg per hour. And our overall mass balance is also balanced on both sides at 1751.43 kg per hour. Next is our energy balance. The table below shows the component and the heat formation of the components. Cultivation and centrifugation's heat formed is negative, thus the reaction is exothermic, while in drying process the heat formed is positive, thus is an endothermic reaction.
For chemical engineering thermodynamics 2 tasks, Gibbs energy, heats of formation and heat capacities data were collected in order to perform chemical biochemical equilibria calculation. Equilibrium constant K were determined using the formula shown in this slide. From the formula, K value is 2.18964 and this value shows that K is greater than 1. From the equilibrium reaction, forward to the left, which is resulting in an increase in the concentration of product and more product are produced. To determine the composition of each component, the relationship of equilibrium constant and extent of reaction show high complexity and non-linearity in finding the solution for extent of reaction. So we decided to use trial and error method in finding the solution. From the assumption calculated, the value of extent of reaction is 0.6815, then the composition value of each component were calculated as shown. Last but not least, the composition data from mass and energy balance were compared with the data from thermodynamics calculation. The percentage error ranged from 5.41 to 100.15%.
Next is our biology task. The table below shows the taxonomic classification of Chlorella vulgaris. The table below shows the comparison of producer cells to select the best cell for a process. And based on the comparison, Chlorella vulgaris is the most suitable and efficient cell for a process. Next is the cultivation and propagation of cells. The source of cells are from fragrant incorporation. The biosafety level is level 1. The metabolic pathway is primary. And the physical factors are light intensity and temperature at 20 degrees Celsius. And the chemical factors are pH at 8. The carbon source, which is carbon dioxide. And the nitrogen source is ammonium nitrate. Next is our carbon source and nutritional composition. The carbon source is carbon dioxide with a concentration of 14 liter per minute, and our nutritional composition is ammonium nitrate with a concentration of 0.75 gram per liter, and ammonium phosphate with a concentration of 0.18 gram per liter.
Friction loss is a measure of the amount of energy piping system is lost due to fluid passing through the pipe. To find the total friction loss, construction loss at the exit photobioreactor plus wave friction in the pipe plus friction in 3 elbows 90 degree plus expansion loss at the centrifuge. So the total friction loss is 0.009692 joule per kilogram. This is the mechanical energy balance equation. We substitute the friction loss value in this equation to find the shaft work. The shaft work is negative 165.74 joule per kilogram. For the performance rating pump, we use centrifugal pump between the photobioreactor and the centrifuge. To find the suction head, we have to calculate the total friction loss first. The total friction loss is 0.000296 joule per kilogram. So the suction head is 140.221 joule per kilogram. The discharge head is 305.956 joule per kilogram. So the pump efficiency extrapolated is 44.66% for the 0.0238 meters square per minute. Based on the pump efficiency, we can calculate the pump power. H is measure of the pressure experienced by the fluid on the suction side. The graph shows the pump performance curve where the NPSH efficiency and head loss against the volumetric flow rate.
In conclusion, Chlorella vulgaris is widely recognized as a safe food and feed ingredient around the globe. Based on all calculations, it has been proved that the total production within a year satisfies the demand in the market. Thus, it is affordable to invest in this plant since it is highly beneficial to our country's need. That is all from our group. Thank you.